Hello friends, welcome back to the class. So in this video we are going to discuss about the rearrangement reactions of 1,4 dienes. So this is a very important reaction, the named reaction. It is called dipymethane rearrangement. So friends, the last class we discussed about the photochemistry of 1,3-butadiene. So in this video we are going to discuss about the dipymethane rearrangement reactions. So friends, remember it is very important topic for examination purpose. So here, so what is a dipymethane rearrangement? Let's see that. So here it is the most common photochemical reaction. This is called dipymethane rearrangement or Zimmermann rearrangement. So we are calling this reaction as dipymethane rearrangement or Zimmermann rearrangement. So what is Zimmermann rearrangement? So simply the photochemical rearrangement of 1,4-diene or 3-aryl alkene. You can take 1,4-diene or 3-aryl alkene. So here this is going to involve in 1,2 shift. So the shifting of first position to second position by a group is taking place through a ring closure reaction. The final product is vinyl cyclopropane or aryl cyclopropane respectively. That means if you take 1,4-diene, the product is vinyl cyclopropane. If you take 3-aryl alkene, the product is aryl cyclopropane. So this reaction is called dipymethane rearrangement. The simple reaction, friends, the photochemical rearrangement of 1,4-diene or 3-aryl alkene through 1,2 shift reaction with ring closure reaction to give vinyl cyclopropane or aryl cyclopropane respectively. So you see the example. So this is a 1,4-diene. So why we are calling dipymethane rearrangement? You see, what is methane? So methane going to have a single carbon. So here, it has the valency 4. The carbon has valency 4. So here you write the 2 hydrogens. So dipy means 2 pi bonds are there. So this carbon is going to have 2 pi bonds. So this is called dipymethane. So this reaction involved by this kind of reactants. That's why it is calling dipymethane rearrangement. So okay. So it is on photochemical irradiation. So the product is vinyl cyclopropane. So this product are the same product but the different isomer, same isomer, the mirror image to each other. These are homomers to each other. When the substituents are present, then products are different, otherwise the products are similar. So this is about when you take 1,4-diene. Similarly, when you take 3-aryl alkene, so 1, 2, 3, at third position we have a aryl group. This is called 3-aryl alkene. It is on irradiation. The product is aryl cyclopropane. The product is aryl cyclopropane. So combinedly, this reaction is called dipymethane rearrangement. So simply, friends, in examination, how they are asking? So they are asking, so write about dipymethane rearrangement with a suitable example. So then what you have to write? So you have to write what is the definition of dipymethane rearrangement. Write this example or this example. So when you write both the example, no problem. And you have to write the mechanism also. Let's see the mechanism. So for the first reaction, so friends, this is 1,4-diene. First position, second, third, fourth, 5. Now it is on photochemical irradiation. So obviously you can observe 2 pi bonds are there. Therefore pi to pi star transition is taking place. On direct irradiation, the formed product is undergoing singlet excited state. singlet excited state. So 1 means a singlet state. So when you write 3, that is called triplet state. So here the dipymethane 1,4-diene undergoes a singlet excited state. So then after, friends, you see here what is happening. So this is going to undergo homolytic cleavage. So this pi bond is undergoing homolytic cleavage. Yes, this pi bond also undergoes homolytic cleavage. So after homolytic cleavage, you see here this is going to form, right? So radical, radical, here also radical, radical. So now the formed 2 radicals are going to make the bond. So we get this product. Is it clear, friends? So now here the formed product is going to have 1, 2, 3, 4. First position, fourth position, 1, 2, 3, 4, because here we have a bond. That's why I am counting from here 1, 2, 3, 4. So this is called 1,4 biradical intermediate. 1,4 biradical intermediate. So what we are saying, this is a 1,4 biradical intermediate. So now what is happening, friends? It is undergoing, right, bond breakage between C2 and C3 bonds. Where is C2 carbon? This is C2 carbon. That means this is C2 and here I written 3. So therefore this is 3. So this bond is undergoing. So this bond is undergoing homolytic cleavage. So when it undergoes homolytic cleavage, you see what is going to form. Yes. Yes. Right. Already here we have a bond. Right, here we have a radical. Now this bond, so which bond here? I am going to highlight the bond, right? So yes, so this bond is undergoing homolytic cleavage. Now this bond is undergoing homolytic cleavage. So the homolytic cleavage of this bond, yes, right, homolytic cleavage. This is called Fischer cleavage, friends, Fischer arrow. So already we have a radical at this position. Okay. So after homolytic cleavage, we are going to get, yes, you can observe, right, sorry, yes, after homolytic cleavage, so this is going to form it, right, already we have methyl groups. Now already we have the radical. So due to homolytic cleavage of this bond, here we are going to get radical and here also we are getting a radical. So now these 2 radicals make a bond. So now the pi bond is obtained. Here we are going to have another radical. So that product is obtained. So I hope you understand what is happening here. So now these 2 radicals combine to each other. So these 2 radicals are going to be combined. So make a bond. A cyclopropane derivative has happened. Now this is, you can observe, this is a cyclopropane ring. So I am writing in proper form. So this is the compound. So friends, otherwise if you break this bond, so you get another isomer. So here there is no substituents, therefore so we are going to get a unique product, a single product will obtain. So friends, this is about the mechanism of dipymethane rearrangement reaction. The simple reaction, friends, you can observe 1,4-diene is there. This 1,4-diene on photochemical irradiation going to form singlet excited state. So now after that, the Fischer cleavage of these pi bonds, homolytic cleavage of these pi bonds, radicals formed at this position, and the formed radicals going, the formed radicals are going to make the bond. So we get a single bond, sigma bond. Now these radicals are formed. Here the formed radical is called 1,4 biradical intermediate. 1,4 biradical intermediate. Okay. Now after that, so you can cleave this bond, or you can also cleave this bond. If you cleave this bond, you get one product. If you cleave this bond, you get another product. So but you remember, friends, when the substituents are different, at the terminal positions, then you have to do two reactions. Otherwise, the single reaction is enough. Now, the homolytic cleavage of this bond, so which bond? C2C3 bond. Now, radical is formed here. So, here also we get a radical. So, this radical is there. Now, the formed radical going to form a bond with the already existed radical at this position. We get a double bond. So, now these two radicals make a bond. We get a cyclopropane ring. So, this is the product I am writing in proper form. So, friends, what is this? What kind of reaction it is? So, this reaction is proceeding via formation of biradical pathway. So, because two radicals are forming in each intermediate, you can see that biradical pathway. So, here the biradicals are formed through irradiation. So, here the substituents present at C3 position. So, this position, the substituent present at C3 position stabilize the intermediates, that means biradicals, intermediates. So, now this rearrangement is going to be retained the configuration at the C1, C5 and C3 positions. So, C1, C3, C5 positions. At these positions, the stereochemistry never changed in the product. So, friends, this is about the simple explanation of 1,4-diene dipyrmethane rearrangement. So, let us take a 3-aryl alkene. So, 3-aryl alkene. So, here, so you can observe there. So, one side we have a pi bond, another side we have a aryl ring. So, this is also similar to 1,4-diene. Yes, we are going to do the reaction. First, irradiation. Obviously, it is undergoing pi to pi star transition. Forms yes, singlet excited state of the molecule. Now, here this bond undergoing homolytic cleavage, this bond is also undergoing homolytic cleavage. After homolytic cleavage, we are going to get, so radical here. These radicals are make a bond. Yes, you can observe the bond has formed, and the remaining radicals are going to existed in intermediate. This intermediate is called 1,4 biradical intermediate. So, after that you see here, friends. So, I am going to break the bond at this position, which side? Towards the aryl ring side, not going to break towards vinyl side. I am going to break the C3 C4 bond towards which position? The ring side. So, now bond breakage between, so it is not C2 C3, it is a C3 and C4. Yes. Now, we get a radical and radical. These two radicals make the bond. We get a aryl ring. So, you can observe here, due to breakage of this bond, we are going to get aromatic compound again. So, that is why we are going to break. So, the bond towards the ring side. So, this bond. So, towards the ring side. Now, these two radicals make a bond. Yes, these two radicals make a bond. So, we get cyclopropane ring. I am going to write in proper way. Yes, this is aryl cyclopropane, phenyl cyclopropane. Otherwise, you see, when the bond is breaking towards C2 C3 side, that means towards double bond side, vinyl group side, this side, what is happening? So, when you break this bond, yes, at this position, when you break this bond, so we get, so these two radicals, here we are going to get a radical, here already radical is there, these two make a bond, so pi bond has obtained. Now, here the breakage of bond going to form a radical here. So, now this is going to, these two radicals are attached by each other, form a sigma bond. So, now the cyclopropane ring has obtained. So, what happened, friends? Here the aromaticity of the compound completely collapsed. So, you know, the aromatic compound is more stable than any other compound. So, but what happening? When you cleave the bond towards vinyl group side, when you cleave the bond towards vinyl group side, this is going to give unstable product. So, but when you cleave the bond towards aryl ring side, it is going to give a again aromatic compound, that is stable product. So that's why, so what is happening, so this reaction, so always takes place through this direction. So this reaction cannot go through this form, this reaction side. So means this branch cannot be happened during the reaction. This branch cannot be happened during the reaction. Just you write this one in the examination, that is enough to us. So this cannot be formed during the reaction. Okay. So friends, this is okay. Let's see what are the characteristics of 1,4-diene rearrangement reaction. So here this reaction takes place in singlet state as well as a triplet excited state, and these are solution state reactions. These will always take place in solutions. So here this is going to form cyclopropyl 1,4-diradical intermediate. The reaction is going to form, yes, cyclopropyl 1,4-biradical intermediate. And here the stereo as well as regioselective reaction. The reaction is stereoselective reaction as well as a regiospecific reaction. Here at the termini of 1,4-diene, if substituents are present, then the products are different. The cleavage of 1,4-biradical preferentially towards unstable radical side. Always this one. So right here, this is a cyclopropyl 1,4-biradical. Here I am going to give the substituents R1. Here also R1 is there. So for example, here I am writing some substituents R is there. So now what they are saying, friends? So here at the terminal positions, if different substituents are present, then the produced products are different. Now the cleavage always takes place towards less stable radical side. For example, this radical is stable. Yes, this radical is stable. This radical is stable. And when this radical is unstable, yes, unstable. Now the cleavage takes place at this bond. That means unstable radical side, the bond cleavage will take place. You have to, yes, remember this point. So right next, so at the termini of unsaturation, if electron withdrawing groups are present, then in the product they will be present on the ring system. Electron withdrawing groups are present in the reactant, then so these withdrawing groups exist in final product on cyclopropane ring. If electron donating groups are present, so these donating groups are going to present on unsaturation. So friends, this is about characteristics of 1,4-diene rearrangement, nothing but dipymethane rearrangement. So friends, so till now we discussed about simple examples, so which are symmetrical. So let's see another example. Actually they are asking this example in examination, a typical example. You observe here, yes, this reactant. So on this vinyl group we have the hydrogens, on this vinyl group we have the pH groups. So therefore the formed 1,4-biradicals are different. So let's see on photochemical irradiation. So first forms a singlet excited state. After that, so the homolytic, after that the homolytic cleavage of these pi bonds going to make a radicals. So this radical make a bond, yes, and here radical are formed here. So now you can observe here, right, this radical is, yes, this one, this radical is primary radical. What is that radical? Primary radical. So that is a primary radical. So now what about this one? this radical is attached to pH groups, So now this is called benzylic position. So therefore this is a benzyl radical, that is you can say benzyl radical. Yes, benzyl radical. You know, benzyl radical can undergo resonance, so therefore it can form more canonical structures. Okay, so now this is primary radical, where it is a tertiary radical or benzyl radical. So you know that, friends, primary radical is unstable. So primary radical is unstable, but benzyl radical is stable. I hope you already completed the intermediates. So benzyl radical is more stable, not stable, it is more stable because of why? Due to resonance, So now, friends, you see two chances are there. You can cleave on the cyclopropane ring this bond or this bond, A bond or B bond. You can cleave A side bond or B side bond. So here this radical is unstable radical, where this radical is stable radical. What they are saying? You always cleave the bond towards unstable radical side. Where is the unstable radical? So this is unstable radical, therefore you have to cleave this bond. So right. So A side cleavage going to be preferentially cleave towards less radical side, less stable radical side. So now you see, when you cleave this bond, we get a radical here. Already another radical is existed. These two radicals make a bond, and we get a new radical at this position. Now these two radicals make the bond. Yes, we get cyclopropane ring. So simply we are writing the compound like this. So this product has obtained from cleavage towards less radical side. So why, friends? After the cleavage, so we are going to have a stable radicals. So tertiary radical, stable radicals. So for example, if you cleave towards B side, not preferential cleavage, even though I am going to do the reaction. So radical going to form a bond, yes, and a radical has existed. So now this is a primary radical, tertiary radical. So now these two radicals make a bond. So we get a cyclopropane ring, and the product has obtained. So after the cleavage, you see, observe these two radicals. This radical is a stable benzyl radical, stable tertiary radical, where this is unstable primary radical, stable tertiary radical. So comparatively, this is a more stable radical. So it is a less stable radicals. That's why you have to cleave the bond always towards less stable radical side. So now the product which is formed from stable radical, that is major, because here this is the stable radical. After the cleavage of bonded cyclopropane ring, yes, this is the stable radical. Yes, so right, this is a unstable radical. So that's why the formed product is a minor. This product is a major. So friends, this is about a dipymethane rearrangement. So simply what kind of example they may give, but you see till here the reaction is similar. Now you focus which side cleavage is going to give major product. So always you preferentially cleave towards less stable radical side. For example, here you see this is the compound or intermediate during a dipymethane rearrangement. Here the groups are electron withdrawing group, Here the groups are electron donating groups, and here we have a radical. Okay, here also we have a radical. Now you see, this radical is attached to donating groups, this radical is attached to withdrawing groups. Therefore, when radical attached to withdrawing groups, that is unstable. Radical attached to donating groups, that is stable, isn't it? So now Therefore, you have to cleave the bond towards which side? Less stable radical side. This bond you have to cleave. So friends, you remember this concept, then you can write the mechanism very easily. So friends, I hope you understand the reaction about dipymethane. So for previous classes, you can see from description, and also you can download the notes from description for all the classes. So I am going to upload the notes for this class also in the description. So thank you friends, we will meet in the next class.